Hi there, we're back with Blitzer's Introductory and Intermediate Algebra for College Students text. We are on section 12.3, which covers properties of logarithms. We'll be learning about using the product, quotient, and power rules so that we can expand or condense logarithmic expressions, and then we'll also learn about the change of base property. So go ahead and pause the video and do these two quick warm-ups and see how you do. Good luck. Okay, so for the first one, we are multiplying the same base. So when we multiply same base, we add the exponents. So you get 5 to the x plus x, which is 5 raised to the 2x. Right? So remember, when you are dealing with exponents and you're multiplying same base, you add the exponents. And over here, you have the same base, you're dividing, so you subtract exponents. So we'll get 2 raised to the 2x. You'll want to keep those in mind because remember, logarithms are good exponents, and so they follow these rules. So the product rule: let b, m, and n be positive real numbers with b not equal to 1. So log base b of the product m times n. Remember, a logarithm is an exponent, so you end up adding the logarithms. So the logarithm of a product is the sum of the logarithms. Okay, so in the first example, we're being asked to expand each logarithmic expression. So for the first one, we would get log base 6 at 6 plus log base 6 at x. Is there anything further we can do with that guy? Good. The power to which I raise 6 to get 6 is 1. So we get 1 plus log base 6 at x, and we're done. All right, go ahead and pause the movie, and why don't you guys try this one? All right, let's see how you did. This one, we have the natural log function, so natural log at x plus natural log at x. Well, wouldn't you consider those to be like terms? They're both the same log with the same quantity inside. So it turns out we have 2 of these guys. Okay. All right, so the quotient rule, again, let b, m, and n be positive real numbers with b not equal to 0. So log base b of m over n is equal to log base b of m minus log base b of n. Because remember from our second warm-up, when you have the same base and you're dividing, you subtract the exponents. A logarithm is an exponent, and that's where this subtraction comes in. So the logarithm of a quotient is the difference of the logarithms. All right. So let's expand each of these. So the first one, we have a common log, so log 1 minus log x. Is there anything we can do with that log 1? The power to which we raise 10 to get 1 is 0, right? So 0 minus log x, which is negative log at x. And that's because log 1 is 0. Okay, so here we go. this one we have log base 4 of x divided by 2. So this will be log base 4 at x minus log base 4 at 2. Now, can we simplify either one of these? Good. The log base 4 at x stays, but this one is the power to which we raise 4 to get 2. Well, the square root of 4 is 2, and so that's the 1/2 power. And so again, this guy has a result of 1/2. Now, typically it will be written like this: negative 1/2 plus log base 4 at x, so that there's no misunderstanding that this minus 1/2 is not inside the log. In order for that to be inside the log, we would have had to put parentheses around the x minus 1/2, which is not the case. Okay, the power rule. So we have one extra blank here, so let's just scribble that out. So here we have let b and m be positive real numbers with b not equal to 1, and let p be any real number. So here, if you have log base b of m raised to the p, that's equal to p times log base b at m. So the p becomes a multiplier. And you actually saw an example of that in example 1, part b. We could have rewritten that as natural log at x squared and used this property. Now this one, again, I apologize. There's I did a copy and paste error here, so we'll just write in the rest of this. So in words, what we'll have is the logarithm of a number with an exponent is the product of the exponent and the logarithm of that number. Okay, so here we go. Log at x squared is equal to 2, the 2 is like the p, times log at x. Now this one we might need to do a little bit of work. Let's write this in using rational exponents. So this would be log base 5 of x to the 1/2. So we've got a 1/2 power, which becomes a multiplier to log base 5 at x. All right. So now here's some properties for expanding logs. So for m greater than 0 and n greater than 0, log base b of m times n is equal to log base b of m plus log base b of n. And log base b of, what do I put here? Good. M divided by n is equal to the difference of the logs. And log base b of m raised to the p is equivalent to p times log base b of m. So let's expand each of these logarithmic expressions. So here we go. This one will be log x cubed times y to the 1/3. So what I'm doing first is I am rewriting these with rational exponents. So now I'll apply the property to expand. And now we can use that power rule. Bring the powers to the front as a multiplier. Oops. And we're done. Now, expanding logs, we do a lot in calculus. So when I see you guys in Calculus 1, we'll be using this technique to make differentiating easier. Okay, so here we go with this guy. We're going to rewrite this as log base 4 of, we've got the x over the 12y to the 5th, and that's all raised to the 1/2 power because it's in that square root. So we can bring that 1/2 outside. We get log base 4 of x over 12y to the 5th. So now the 1/2 will become a multiplier, and we'll have log base 4 of x minus log base 4 of 12y to the 5th. Now that's going to be we can split that as a product, so we're going to put it in parentheses so we don't just forget to distribute the minus to both. So we'll have log base 4, 12, and then we'll have plus log y to the 5th. So this will be 1/2 log base 4 at x minus log base 4 at 12 minus, now that 5 is going to come out front, and we'll have log base 4 at y. And we're done. All right, so what we'll use mostly here, to solve equations is this property for condensing logs. So again, for m greater than 0 and n greater than 0. So this is when you have, the logs are expanded and you want to make them, so log base b of m plus log base b of n is equal to the log base b of the product. This one, log base b of m, minus log base b of n is equal to the log base b of the quotient. And p times log base b of m is equal to log base b of m raised to the p. So here we go. We'll go ahead and condense these. So this will be natural log of x cubed from the first term minus natural log of x minus 2 to the 1/4 power. You got to check and make sure you've got the same, you can get tricky with condensing. You got to make sure you have the same base. So both of these are natural logs, so we have the same base. So we now can look at condensing it into 1. So we'll have natural log of x cubed over x minus 2 to the 1/4, or you could write this as natural log at x cubed over the 4th root of x minus 2. Either one of these is fine. Okay, so for this one, they're both of them are log base 4, so we're good. So this will be log base 4 of 5 plus log base 4 of x plus y raised to the 12th. Now we're all set to write this as one happy product. So we'll have log base 4 of 5 times x plus y raised to the 12th. We're done. Now the change of base property is as follows here. So for any logarithmic bases a and b and any positive number m, it turns out that log base b at m is equivalent to log base a at m over log base a at b. So the logarithm of m with base b is equal to the logarithm of m with any new base divided by the logarithm of b with that new base. So why would we use this property? Well, I mean, look at your calculator. Our calculators only have the log key and the ln keys, right? So if we had log base 4 of 5, we need to convert to either the common log or the natural log. All right. So here we are. Whoops. So first step, use common logarithms to evaluate log base 5 at 23. So log base 5 at 23 equals, using common logs, it's going to be log 23 over log 5, which is going to be approximately. So here, this is a graphing calculator, so the log commands are going to come before the numbers. So this is going to give us, all right, so we have log 23. Now you got to make sure you end the parentheses before you hit the divide sign. And then we'll have divided by log 5. And we get approximately, what was it? I'll copy this for you. So we would get approximately 1 point, I don't know, we can go to the, let's go to the nearest hundredth, 1.95. Okay, now use natural logarithms to evaluate the same one. So log base 5, 23 is natural log 23 over natural log 5. So that'll be approximately so natural log 23 divided by natural log 5 is, what do you know? You get the same exact answer. Pretty cool, right? So 1.95. So what did we find out? You get the same answer, right? They give the same answer. So it doesn't matter if you pick common logs or if you pick natural logs, you'll get the same result. All right, and that wraps it up for this section. Have a fabulous day. Don't forget to do some problems from the problem set. All right, bye.